Welcome to Mavens of Data. This week we're speaking with Andriy Burkov, author of the 100-page machine learning book. Andriy shared all about working with LLMs and talks about what is often misunderstood. I hope you enjoy this episode. I would love, before we dive in, if you'd just like to say hello and then tell everyone a little bit about your background if they're not familiar with what you've been up to.
I'm Andriy Burkov. 6 years ago, I wrote a book on machine learning, and the book was super popular. And I wasn't sure that I would write any more books because my my goal with the first one was to write the book of machine learning. But 3 years ago, large language models happened, and they changed a lot in machine learning. I wouldn't say that it replaced everything that I wrote in the first book. It's more like an advancement of this or complementary thing. So I decided that now it's the moment to write a sequel. And so I've done a PhD in artificial intelligence in 2010, and it was time when probably Google, maybe Facebook, they did machine learning, but for a regular folks, it was still very kind of terra incognita. So things changed very much, and now in 2025, everyone talks AI, and I try to keep people informed about what's real and what's not, because there is a lot of hype around it. So yeah, I hope that today we will be able to talk about what is really is, what is possible, and what's not working that well, and what can we do to still leverage it in business.
Awesome. Yeah. And I hope that even though you're sick, you're able to bring your trademark edginess to the conversation. So to jump right in, what are you seeing in terms of what's misunderstood with LLMs, right? Because it is new. And like you said, in 2010, there was a couple companies doing it. And then a couple years later, we all started talking about machine learning, but no one was actually doing it, right? And now we're sort of at the point where everyone's talking about LLMs and people are just starting to actually do it. Like, it's almost the same sort of trajectory that we saw with machine learning. So as we go through this transition, what are we seeing in terms of, the struggles people are having trying to implement this?
Yeah, well, I think that the biggest challenge for many people, especially those who are not coming from science, like from scientific community, is this perception or that AI is actually intelligence. So it's artificial intelligence, so it should be intelligence. But AI or artificial intelligence is just a term that scientists use in publications so that they can understand each other. So they talk about the same thing. So they needed something short, something short to refer to, and they invented the term artificial intelligence. But for regular people, people who are new to it, they might think that, okay, it's intelligent, so it's intelligent like I am, or like my my colleagues, my friends. So I can use it as I would use a person, and this is very it's wrong. So the biggest challenge for people is to understand that if it does something and you think that it solves a problem, you cannot extrapolate it, and you cannot really say, okay, for example, you can open an LLM and type something like, I need Python code that implements the game of Tetris. And it actually prints it, and you run it. Oh, wow, Tetris appears right away on your screen. And you think, oh, well, this is really intelligent. but then you will ask a very basic question about your specific domain where you work, and you will get an entirely wrong answer, or something like in between. And you would think like, how could it so quickly and easily write the code for Tetris? And like it's a complex thing, like it's visual, it's a game, so it should accept inputs, and it should draw pictures. And then I ask something something very simple about my domain, and it cannot do it. So the biggest thing is for people to realize that like it can be very, very fast and effective in one thing, and entirely useless in a different thing. And you don't know in advance where it will be helpful and where it will waste your time or even be dangerous. And this is where I think people will take time to realize that it's not extrapolatable. So if it does this, it doesn't mean it will do that, as you would expect from people.
Yeah, no, I had that experience. I have a friend that's a math teacher, and she's like, "Oh, I asked it this question and it couldn't answer it." And I was like, "I know. Well, it's trained on language, and with LangChain and other things, it's getting better at doing math. But at the same time, in my head, it's like, there's a vector database set up there with words. I wouldn't expect it to do math." And then I just actually sort of felt like a jerk. Because I need to be a little bit more mindful when I'm talking to people about these things. But so how do you approach, if we get into sort of how we're actually implementing these LLMs, to like start at the beginning, how do you actually approach extracting and normalizing information for input into an LLM?
Well, I think today's LLMs are quite capable in understanding different formats of data, and I often use it. For example, when I there is an article and I don't want to spend an hour reading it, so I just copy the article from the web, I paste it in the LLM without any preparation, and I ask a question. For example, what is the main idea, or what are the three important things that I can learn from this article without reading it entirely. So like today, the preparation of the data for LLMs becomes much less important than as it was, let's say, a year ago, when everyone talked about prompt engineering and said that, okay, prompt engineer, it's a profession. It's a profession of the future because machines cannot understand human language well, and you need to be able to write well so that the machine can understand you. So today it's less of an issue. So I think what's important when you send inputs to a machine is to think as a machine learning engineer, and think about the limitations of what the model can actually understand, not in terms of how to write it, but in terms what to write. So, for example, these language models, as you said, they are trained on text. So the first thing when you communicate with an LLM about your specific problem is to think about what is the chance that the LLM you talked to was trained on some text that might be helpful to solve your problem.
Mm-hmm.
So, for example, let's say if your problem is, I don't know, extract entities, like, for example, you have a document, and in the document you have, let's say, people names, locations, company names, then the chance that the model will be successful are quite high, because like named entity extraction or recognition, it's a long it's a problem that scientists have been working for decades. So there is a lot of data, training data for this online, and you can be 100% sure that some of this data was in the training data for the model. So if you just paste some document and say, I need all locations from it, there will be locations in the output. Maybe not all, maybe 90%, but they will be. But then let's say you work for a company that, I don't know, it's a company that builds some very specialized equipment for construction. So what, in your experience as an expert, how easy it is for you to find information about this very specialized equipment online? Probably not that easy. Probably you need to visit some specialized websites of vendors, of construction companies, maybe even log into their kind of documentation systems, and only then you can probably download something useful. So in this case, you cannot really expect that the LLM will be as successful with this specialized vocabulary as it is with named entity like locations and people names. So in this case, you need to be more like, you need to think, okay, I think that the model was not trained on this kind of data. So I first need to explain to the model what this data is, what it looks like, what it can and cannot contain. And only then I will ask my question. So yeah, so think about like whether the data you talk about is part of the training data or not, and this change the way you prepare your inputs for the model.
Mm-hmm. I've also had the issue. So I was building an LLM application for a healthcare consultancy, and we wanted to give outputs at a third grade reading level for Medicaid populations, right? And we just sort of like tiered it by the different type of program that people were in. And the problem that I found was that for reading grade level, there's a ton of different ways that people define it. And so it is something that's available on the web. There's like plenty of material that talks about reading level, but there's just so many different ways that people could evaluate it or that they think about reading level. And so we really had to break it down in terms of like, it's not, I can't say like, I want third grade reading level. I had to say like, I want sentences less than 10 words long. I want words that are less than, 2 syllables or less. I needed to, break down every little piece of what that is. Whereas, there's things like, hey, I want you to write in this tone. I want you to not use exclamation points. I want you to, all these other things that you'd want as part of a professional letter that were super easy to achieve. And then you run into these wrinkles where it's like, no, actually, I need to really break this one down.
Yeah, and you talk about the second aspect. So like there is something that the model cannot know like inside your head. So your definition of thing maybe not exactly as it was defined on average on the web. So if you really care, like if you really need the model to reason about your specific understanding of something, you need to provide this understanding first. So you need to really define it before you ask questions about it. Yeah, this is right.
Yeah. No, and some other issues I've had, right, is that like most of the projects that I have built have been on a very simple data set. I add my data set to a vector database. It's very, the schema is not that interesting. I don't have a ton of metadata. What are the types of problems that we run into when we have like a more complicated taxonomy, or it's like, just a much more interesting problem than what I've been working on?
Yeah, well, this is actually a very important thing too. And again, it was different, let's say, a year ago or 2 years ago. Now things are different, but still the problem remains. So what I mean by this is that when LLMs first appeared, like the ChatGPT, for example, I think the context was 4 or 8,000 tokens in the beginning. So after this, it wouldn't be able to pay attention to your longer inputs. So for example, let's say you work with a proprietary taxonomy and you need, for example, to show a document to a model and say, you need to classify the document according to my taxonomy. So previously with this 4 or 8,000 tokens limit, it was hard to put the entire taxonomy in the prompt and then ask a question about the document. But today, most models support at least 100,000 tokens. The most advanced, like in 2025, have at least 250,000 tokens, and some claim 1 million, 2 million, 10 million. So today it doesn't seem unimaginable to actually put a very complex, a very long, and very kind of specific definition of every element in the taxonomy in the prompt entirely, and then put a document and ask questions about it. Of course, there is no guarantee that the model will pay attention to every element in your taxonomy and will not miss any important detail that is important for you, but the model will think, okay, well, think in parentheses. So it becomes very similar to what we had as machine learning engineers or data scientists before language models. So we created a classifier. So we actually provided documents to a model, and we said, okay, for this document, you need to return this element of this taxonomy. And for that document, you need to return that element of the taxonomy. And the more example of such training examples you provide, the better your classifier becomes, but it never reaches 100%. And it's the same about LLMs today, but well, the same, but with some important difference is that with machine learning approach, when you actually train a model, the more data you put, the better your model becomes. Again, never 100%, but you still can approach gradually the desired level of performance. But with LLMs, you will eventually see that you reach some sort of level where it doesn't improve anymore. But you can still provide additional examples, and you can still provide additional explanations. But you see, it doesn't improve it at all. So with LLMs, this I call it a kind of a saturation point. So like you reach a certain level of performance, and there is nothing you can do with prompts to improve it. So in this case, what we recommend, what I recommend for people to do, and I do it myself, is like if you see that with prompts the performance is no longer improving, switch to fine tuning. Currently, most of the LLM API providers provide some sort of fine tuning on your own data. Usually, you will get a better performance with fine tuning. Yeah.
That's awesome. Yeah, no, I think so. The last LLM I built at that point in time, I think a lot of fine tuning wasn't available yet if you were using an API. And of course, small language models and model merging and things like that are going to allow doing things on-prem and downloading a model to your machine is going to become more common. And then of course, you can fine tune. Do you have any sense? And I know, we hadn't talked about this previously, so I don't know if you do, but do you have thoughts on if companies are going to really have an appetite for small language models on-prem, or if they're currently using them, or are we all, because, the last couple of years, everyone who's been doing it, we've all just been hitting an API and building our apps around it that way.
Yeah, well, I worked with small models. Well, currently we should define what small is, because 3 years ago, small was considered maybe 50 million parameters, 100 million parameters. Today, small is probably at least 7 billion. Some say that 20 billion is small. So I worked with small models, and I think that there is potential for small models as fine tune for fine tuning. So I think that with small model and enough good quality proprietary data, you can have a better performance for your specific task than a large generalist model. But at the same time, a large generalist model with proper fine-tuning will also probably give you a good performance, probably better than a small model. So the only difference, like in practice, is that when you fine-tune a large model with APIs, they use the so-called LoRa fine-tuning. So it's an adapter. So it's a kind of a set of additional weights or parameters that they inject into their original large model, and they only fine-tune this small set of additional parameters by keeping the rest of the original weights the same. So these LoRa adapters, they provide a way to improve the model performance on your data, but again, they will saturate at some point. So you will want more parameters, but probably some providers will say, no, the larger adapter I can train for you is X. So if this larger adapter is X and you need even higher, level of quality, then you will probably say, no, I will rather fine-tune a smaller model, but with more parameters than this LoRa adapter and get a higher performance. But I think that this kind of cases is not for everyone. So I think most people will stay at the prompt level. So they will just say, okay, I will squeeze the maximum from the prompt, and fine-tuning, someone else will do it. Then probably, I don't know, 20% will still say, no, I will fine-tune with LoRa, and maybe, I don't know, 5% or 3% will say, no, I will fine-tune, do the full fine-tune. And to do the full fine-tune, usually you cannot use APIs. So for this, you need your own equipment. And again, there is market now for everything and everyone. Now there are companies that provide you GPUs, and there are companies that provide you frameworks for full fine-tune. You don't even need to, have this equipment physically. You don't even need to work with GPUs directly. So everything is virtualized, everything is abstract out. So for every client now there is market.
Yeah, no, and I have heard that too at the I was at IBM Think, and they were talking about how, actually I've heard from a number of companies that the small specialized models are outperforming now a lot of the larger models. And we're also hearing a ton about agents, and these systems are getting a lot more complex. And so when we have autonomous agents driven by LLMs, like, how brittle are these systems when a report changes or something changes? Like, I feel like we're talking about how much we're able to do, but also how difficult are some of these things still? Like, how brittle are some of these systems, and what are the realities there?
Yeah, well, for everyone who tried to code with LLMs, the process some refer to as vibe coding. These people know, and because I'm in it, I've been in it for the last couple of months. So there is no one model that will code or that will fix your bug. For example, let's say you have a bug in your code. There is no one model that you can say, okay, I will stick to this one and I will build my application. This will not is not going to work. So usually what people do, and people hate it, and I don't know if it will change at some point, but people open several LLMs, the most capable ones. Let's say currently it's Claude 4 from Anthropic, ChatGPT 3.0 from OpenAI, Gemini from Pro 2.5 Pro from Google, and let's say, what else? Let it be these three. So you put your code and you explain the problem, and you say, okay, I need a fix. So the first one will write the code and you will run it. It doesn't work, and you can continue with the first one. You can say, no, it didn't work. and it will say, oh yeah, okay, I know now what it is. It will give you the second version of the code. You run it, again, doesn't work. So you can stick with this model forever, maybe spend a month, and they say, no, doesn't work, no, doesn't work. Or you can switch to a different model, and like this, it will solve your problem. And you're like, oh, wow, this second model is superior. No, because if you stick with the second model, then you will get stuck on another bug, and the first model will solve it. Why does it happen? No, people don't know, but the hypothesis is, as with everything in machine learning, is the underlying data. So maybe some model was trained on a problem similar to yours, and another one wasn't. I think that it has something to do with kind of a optimum to which the model converges during training. So let's say in the optimum Gemini converges to, this specific problem wasn't the performance on this specific problem wasn't maximized. So if you switch to a different version, it could be. So currently, you cannot really say one model is better than the others. And this is why probably, well, yeah, we will talk about the agents, but in general, you cannot really say, okay, I have this agent for this problem and it will solve it. You can just cross fingers that it will, but when it fails, what do you do? So you will have probably 3 different versions of the same agent, and if the first failed, you will run the second one, and the second failed, the third one. But in the end, you don't have an infinite choice of models. So at some point, if all of them fail, then you will have to open the code, look inside, and see, okay, why does it fail? Okay, let me run the debugger. And so if you do it as a hobby, like if you just do it for fun, if it failed in all fronts, you will like, okay, too bad, I will try next month. But if you do it for business, you cannot really tell your client, my 3 agents failed. There is nothing else I can do. This is not how business works.
No, and that's 100% been my experience. I tried vibe coding, and I don't even know, exactly what the definition of vibe coding is. Like sometimes I hear that it's somebody who doesn't know how to code and is coding or whatever, but I was building a music similarity search app, and it was my first time playing with audio data. And so I'm using the Spotify API. And I kid you not, and I mean, it was amazing. It was so you give it a song and it recommends songs that, I saved a bunch of metadata so that there were filters so that I could get songs that were very similar to, I was trying to get a solo dance song for my daughter, right? And so I'm vibe coding, and I'm having problems. And so, I get an error, and I ask ChatGPT, and I'm like, what's up? And ChatGPT literally told me to like create a new developer account, right? Like the old, like turn it off and turn it back on. And I'm like, okay, this isn't it. So I'm asking again, and it comes back and it's like, try a VPN. And so the moral of the story is that you still have to, right? Because then at that point, it's like, I still got to go look at the docs. I'm going to check Stack Overflow. And what happened was, there was a change to the API in just last November, so November 2024. So to your point, talking about how much data is available online, it was probably only mentioned, in 1 or 2, 3, 4 spots, a couple spots on the internet. So there wasn't this huge repository for it to pull from. But 100%, when that happens, it's like, you've got to go back to old methods, which, I feel like with vibe coding, you still have to know your way around. You still have to be able to, how much time have we lost in our lives just dealing with dependency issues? It's not something that you can get really far, but once you get stuck,
yeah, it's a question. Do you want to finish or not? So if you don't want, if you don't care that you might not finish, white coding is a way to go. You can get stuck at 95% and say, well, I was this close, but if you really want to finish this 5%, you will need someone to be able to finish it. And this someone, I'm 100% sure, will be unhappy if you say, well, this is my 95%, I vibe coded. Now, please finish the remaining 5%. usually if you have an experience working with developers, they're unhappy to work with someone else's code. But this is not someone else's code, it's some things code, and they will be unhappy times 10 working with it.
No, I say it was Vin Vashista the other day had posted on LinkedIn about a story. I don't know whether it was true or not, but getting a call at 2 a.m. to fix vibe coded code in production. And I can't even imagine how red my face would be if I got woken up from someone putting code in production that just like really didn't belong there. And I commented on it, and a lot of the responses were like, well, maybe it becomes something like you get a consultant sort of fee, and like you're on call, but it's extra pay or something. And I don't know if that'd be I just could not see developers being okay with moving forward with that type of model in general, or maybe there are enough people that would be okay with that.
Well, what I predicted in some one of my posts recently is that in 2 or 3 years there will be a huge market for companies fixing the vibe coded code, because many companies today, they say put in production, we just need to beat competition, and they put in production so much of this vibe coded code, if we can say it this way, and they don't care, because they say, well, in the future, when it works and we have clients, we have money, we will fix it. And when it's time to actually fix it, no one will want to do it internally, so they will outsource it to some company that will say, give me your vibe code, we will rewrite it fully or try to fix it, and we will provide you some real maintainable code. And it's okay, because like today the economy moves so fast, and they say fail fast rather than slow. So people will try to fail fast, and if someone succeeds with this vibe code, they will have to rewrite it at some point.
Yeah, I mean, I almost get that for a startup, a small company that's starting, but when we're talking about like a huge enterprise company with like a massive complex code base, it seems so silly when your developers are writing the code that allows you to make, millions of dollars in revenue. Why are we going to cheapen it? Like, why is it not treated like something that is just a little more important, because it literally is your product in a lot of cases, not everywhere, but in a lot of cases.
Yeah. Well, I think that to start something, with vibe coding is really cool, because
Yeah.
you can have something up and running like in no time, in 2 hours, in 3 days. It could be unimaginable. It would be unimaginable like 3 years ago or 5 years ago that you will have like a minimum viable product in this short amount of time. But then going forward is hard. But some might say, well, going forward is always hard, so you just add one more problem to it. But there are plenty of other problems, to get customers, to advertise, to do support, to hire people. So when you have a minimum viable product and people like it, then you will say, well, I will hire a good developer who will rewrite it from scratch. It will take 3 months, and then we will go from it.
No, and that's the perfect use case, right? And like anyone who, if you want to try and play with something new, there's never been a better time. If you want to play with computer vision or audio data or LLMs, like you can learn a ton, and you can build an LLM application in 3 hours in an afternoon and have a better understanding of vector databases and RAG and, everything. Like, it's absolutely amazing. But there's like a time and a place. And there's also a ton of other implications, right? So we're seeing all different ways that people are now using these. And so I think you had mentioned previously, and I'd love to hear your thoughts, is that a lot of people now are using LLMs for like mental health support. and the EU has said no, that's not going to be allowed. Like, what are your thoughts on LLMs being used that way and the implications, and just generally,
Well, it's a hard question because I have like both arguments for yes, it's a good idea, and probably it's not a good idea. So like I can give my own example. My cat died
sorry.
last month. Yeah, and I took it really hard. It was my first animal, and like my whole life, I didn't want to have animals because I didn't want this specific moment to come. But I kind of inherited him from my previous relationship, so he left with me and he died, and I took it hard, and I think asking questions to LLMs, did I do everything I could? Was I a good master and so on? Uh, it helped. It helped. I really felt like it helped. It explained that no, I did everything well, and so on. So from this point, I think it's great. Not everyone can afford to go to a psychologist or to some personal support when something like this happens. And things can happen very fast. You cannot be ready for it. You cannot really have thought about it, and now you need to deal with it. So I think from this perspective, having access to such models, and they actually were trained to like fine tune to support people in such situation. It's clear because you read from the text that it's not random. It's actually really well thought the way they responded. So I think this from this perspective, it's great. What we don't think, what we don't know is when it doesn't work for some, how bad it is. I mean, if it's a wrong kind of advice the model gives, because there will be wrong advices. It's no doubt about it. How wrong they can be? Can it trigger something destructive in the person? Something like they were already on some edge, and now the model pushes them farther. We don't know, and from this perspective, just blindly say, yeah, it's a good idea on average, so let's allow such services to everyone. I think we need some more research to see how bad things can be if a person gets a wrong advice from an LLM. Maybe we exaggerate. Maybe it will not, give advice, go kill yourself or something like this. Maybe we just, our imagination. But we really need to do some research, some test groups, and so on before we can actually say, yeah, like the chance that it will make your situation worse are negligible, but the benefits for the rest of the population are measurable, and they're good.
Right. Well, I even worry about and I've seen this has already been like a topic, so I'll just mention something and then we'll move on. But I'll be working on right now. I'm writing a blog article, and it covers the information coefficient for like a back test, an algo trading back test. And so it looks at like the mean, the standard deviation, the t-stat, the p-value, the skew, the kurtosis, or whatever. And so I'm writing a blog article on this, and I'll ask something that I want to clarify, and then it'll be like, oh, good catch. And it's like, no, that wasn't a good catch. Like, why are you fluffing me up? Like that was, and so I worry too that there's not enough like just honest, hey, you've got some room to grow if you weren't actually thinking about that, or just being a little bit more just honest and direct, right? But to sort of keep going, how I've used LLMs before to sort of get the sentiment analysis of, right? So I was at MoneyGram, we were building LLMs, And then it came time to analyze these LLMs. And of course, there's like traditional sentiment analysis. And then it was also, hey, well, we have an LLM. Let's use an LLM to analyze the results of the LLM and get some diagnostics there in terms of how people are feeling about this, what the big complaints are, all that sort of stuff. In general, what do you see as the problems with sentiment analysis and how that all works?
Well, I think that it turns around the same thing. What it was fine-tuned on or trained on, so the model. So and also like I know that people like to say LLMs are just pattern matchers, and others say it's oversimplification, but it is they are pattern matchers. Is that the patterns that they are capable of matching can be very complex. So when you talk about sentiment analysis, like the notion of sentiment is something from us, right? So it like we feel something. The LLMs they don't feel. So if you fine tune your LLMs on some examples of sentiment that you as a user share, then the LLM will produce results that you will find compelling. But sentiments are different from in different people in different situations, and those patterns in the data, they might indicate two different sentiments to two different people, or the LLMs will just not wasn't trained on this specific aspect of this specific situation, and it will predict the wrong sentiment according to some person or according to all people. So like you really need to if you want the sentiment analysis to work perfectly for you, it should be trained on your own sentiment. So you will have to read those documents or those evaluate those situations and then provide how you would feel about it. And like if you provide enough examples of this of your understanding, the model will pattern match them well for you. But then if you wanted to be used so the result of your work to be used by other people, they might disagree with your assessment of sentiment in some situations, and they will blame AI, that AI is not good enough. It's just that their assessment of the same situation is different from yours. So yeah, so like for very simple sentiments like positive, negative, neutral, I think most of us agree that the movie was good, that it's a good sentiment. And someone they say the movie sucks, well, in this case it's a negative sentiment. But the nuances in between they are different from different for different people, I guess.
Right. And the problem is that like positive, neutral, negative isn't very useful to us, right? Because those are very wide bands. And I think my experience was that I actually did a manual analysis of a chatbot where I was going through the data of these chats, and I had to look at, where were people mad? Where was the question actually not answered? Like 85% of the time, people were getting sent to an agent anyways because the bot wasn't performing correctly, right? And so being able to use the LLM actually, I mean, it didn't replace, because I did both. I was doing both to see if it was like actually working correctly. But the idea that you don't have to do it manually made the sentiment analysis with the LLM useful. But then at the same time, we're now getting better diagnostics from all the companies that are working on observability and LLMs, where like, I assume that, we'll have like great metrics and analysis on like whole agent systems holistically, and then you won't be feeding your chatbot output to LLMs like I was doing to get output of like, hey, what did you think of this? What were the main pain points? What's the overall sentiment? So and I think we're getting there. I think we're actually getting there.
Yeah, and actually, like you talk about using one model to generate inputs to another model. It's an actual time saver because, like for example, my team worked on a chatbot, and the chatbot was supposed to support users in their information requests. And how do you simulate what a user might ask? You can brainstorm and write by hand 10 requests that your user might ask, but then your imagination eventually will dry up, and you will get stuck. But with LLMs, because they produce randomly sampled tokens, and you can say, okay, this are my 10 10 situations that the users might be in. I need you to generate 10 more, and because it will match patterns, and you will randomly sample tokens, you will get 10 more, and they will be similar. Of course, there will be some situations that you will say, no, this would never be asked by my users, and you can remove those examples. But the initial pool of examples to choose from are very good. So LLMs are very good in producing this.
Yeah. Let's head over to Q&A. Are you ready, Andriy?
Yep.
Okay, perfect. So, are you currently working on a new book or project? Can you share anything about its focus?
Yeah, so I'm currently working on a new book in the 100-page format about reinforcement learning. So the working title is the 100-page reinforcement learning book. I have advanced quite a lot in the first chapter. It's close to finish, but as I said, like I've been working on a new project with a lot of dedication. Like it will be announced soon, hopefully. So it will be a self-learning platform. So I put this writing temporarily on hold, and once I launch my platform, I will get back to writing. So I think by the end of this year, we will have the 100-page reinforcement learning book ready.
Awesome. That's awesome. Right. And you left a full-time work to be able to work on this exclusively, right?
Yeah, so this is why I had to do it, because I spent about a year working on the language models book, and it was really hard because you do your full-time job, then you can go home, you do your parenting job, and then at 1 a.m. You have time to write, and it's hard to work this way. It's very taxing on mental health and on health in general. So I decided that I will focus more on writing, and I'm happy with people who support me. So there are people who to subscribe to my newsletter and pay monthly, and this allows me to connect the how they say it, connect the ends.
That's awesome. All right. So Mark has asked, how do you troubleshoot issues with LLMs?
Oh, well, it's a very general question because issues can be of different kinds. So I think if you talk about coding, then there are different techniques that I developed over time that allow me to see when something is not working, and to kind of reorient the mindset of the LLM in the direction of solving problems. So like if we talk about coding, for example, So one thing that I noticed, and I follow this this rule from for some time. So basically, you give your code and you ask a question about this code, or you say this code contains like a problem, you need to fix it. So if you see that in the answer from the LLM something is off, anything, it can be entirely anything, and if you see that something is off, don't continue in this session. Start a new one from scratch. So rather than telling it still doesn't work, it will not help. Just start a new session and ask the same question again. Maybe rephrase your question, state it somewhat differently. So, and when I say something is off, it can be anything. For example, let's say the model, you provide the code and you say, for example, this code is partial and it contains just some of the files that you might need. But if you need more, you need to ask question like, what code do you need? And if the model asks a question like, show me this file, and you know that this file is part of your initial input, something is off. Because normally, if the model understood your input, it wouldn't ask you to show a file that you already provided. So in this case, just start a new session and see if in the new session the model no longer need the file that you already have shown. You have higher chances that the code it will write will make sense. So there are different tricks like this that you usually develop with experience, and I will probably write an article about it at some point.
Yeah, and just to chime in too, from my experience, if I'm building a context-specific LLM application, I've had multiple clients that, I say, we need your data to put in the vector database to work with this. So a lot of times, either the problem is that they haven't given us enough data, like it's the same issue that we have when we're building traditional machine learning, like give me more data. And then, I found that between getting more data and with the just tweaking the prompt template, I'm able to fix the majority of things. It really often for me does not need to go any deeper than that. What is the future of LLMs? How long do you think the bubble will last?
The bubble will last as long as investors have hope to win over, to challenge Google. So Google lost it in the beginning. Google wasn't ready to compete when ChatGPT was just out, and for the first year, Google let OpenAI to be the leader in this market. And currently, people say you can ask ChatGPT, and this is a big problem for Google, because previously people said you can Google it. But now they say you can ask ChatGPT. They don't say you can ask Gemini. They don't say you can ask Claude or DeepSeek, right? So they say ChatGPT. So it's a challenge. Google lost it, and some hope that by investing more in LLMs, you can become the next Google. And it's a huge prize to win, and many investors are ready to invest a lot of money into it. So as soon as Google will release a model that is the top of the market, and will demonstrate that, let's say, for a year no one could challenge it, investors will start losing interest in it, and the bubble will deflate. But we don't know how long it might last. It might last a year, maybe 2, 3. No one knows.
All right, we only have time for one or two more, but if you could go back in time and give your younger self one piece of career advice, what would it be?
Oh, I think the biggest realization for me as a nerd was that human connections or people connections are very important in business. So I for the biggest part of my life, I thought that just your knowledge, your intelligence, your persistence, your ambitions, they mean a lot. for your success. I mean, they are the biggest drivers of success. But in real life, you see that connections are, I would say, more important than what you can do. So because if you are well connected, even the things that you cannot do, other people will be able to do. But if you are not connected and you try to do it all on your own, you might succeed or not. But it's just that connections will be there all the time, and you will be able to leverage them. But what you personally can do has limitations. So yeah, be connected, know more people, and this will give you much more tools than just what you personally can do.
I love that. Okay. Last one from Richard. How hard is it, and what does it take to move into ML from DAX SQL coding, so an analyst type role, to move to ML?
I think today it's much more, it's much simpler than it was. So one of the advantages of vibe coding that we haven't discussed is that it's really cool for self-learning, and it's really cool for quick ad hoc interactions. And in data analysis, it's often such quick ad hoc interactions. For example, what previously the work of a data scientist was, you open a notebook like by Jupyter or Google Colab. So you write some data manipulation code to prepare to read from files, to kind of convert, extract some features, then feed those features into scikit-learn or PyTorch or whatever. Then you get your model, you do some visualization. So all this you did by hand, and if you didn't know how to do it, you would have to learn it somehow. But today with LLMs, you can just explain, okay, I have this file. In this file, the data is organized this way. So first of all, write the code that will read the file from a local drive and parse it. And then once you have your data parsed, then you will say, okay, now I want to train a model that will take feature 1, 2, 3, 4, 5 and predict classes 1, 2, 3, 4, 5. So you just explain it verbally, and it will write all this data preparation, all this feature extraction on its own. So you will have your notebook ready to run, and even if you don't know something about how it was supposed to be done, you will read it in the code, and next time you will know how it works. So you learn and you work at the same time, and it's much faster than before.
Yeah, and you can leverage that code again and again. You build an app, and then the next time you go, you open up your Python script that has, the code to write an app.
Yep.
Amazing. So Andriy, thank you so much. That's all the time we have today. Thank you so much for joining. One last question. If people want to find and follow you, what's the best way for them to do that?
Well, I'm easily findable on LinkedIn with my name, or on Twitter with my last name. And yeah, just join and follow my updates. I post several times a day when I've got some clever ideas to share.
All right, awesome. Thank you so much again. I really enjoyed chatting with you. This was great.